Okay, the next lesson we're doing is using the binomial theorem. Now, it looks pretty complicated, but again, just like yesterday when we were doing Pascal's triangle and using that to expand a binomial, the binomial theorem becomes very useful. In fact, I think it's more useful than Pascal. Pascal's triangle is great if you're expanding something that has degree 8 or lower. Once you get into higher degrees, the binomial theorem becomes the more useful theorem to use. Looking at this whole thing, look for the patterns. Look at the pattern of a to the n, a to the n minus 1, a to the n minus 2, a to the n minus 3. Last term, no a or a to the 0. And look at the terms of the b. First, there's no b at all, or b to the 0, b to the 1, b to the 2, b to the 3, and so on, b to the n. If this was a plus b to the 15th, this would be b to the 15th. Okay? This would be a to the 15th. Now, the interesting part is how we get those coefficients. Notice this is a n, so that's an n, or the same number. If this was 15, that would be 15. This would be 15 minus 1, which would be 14, over 1 times 2. This, if we were using 15, 14, 13, 1 times 2 times 3. Do you know what the next one would be if we were using 15? It would be 15, 14, 13, 12 over 1 times 2 times 3 times 4. What would be our exponents on our a and our b? It would be a to the 15 minus 4, which would be 11, and b to the, what do you think, 4th. Notice these exponents always add up to 15. Remember I said pretend we're doing a plus b to the 15? Following this pattern is very cool. In fact, you can use binomial's theorem to find any one term in this whole thing. All right, if this is a plus b to the 15th, do you know how many terms are in that? There's 16 terms, right? Suppose I wanted the 10th term. And I don't want you to figure out anything but the 10th term, so I don't want you to write the whole thing out. Here's how you do it. Write a fraction bar. Write the 2 parentheses. Now, if I want the 10th term, this exponent is going to be 1 less than that. So it's going to be 9. What do my exponents have to add up to? 15. So what would this be? A 6. All right. What goes here is the a. What goes here is the b. What numbers am I going to write up here? 15 times 14 times 13 times 12 times 11. What am I going to write underneath here? 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9. Oops, I need one more there. 10. Okay. So there's how to do it. Okay, so now what I've done here is I've written up the binomial theorem and how to use it to find the 10th term. And basically, if I want the k plus first term, I use this pattern, n factorial over a to the n minus k, b to the k over n minus k factorial times k factorial. And I just realized you guys don't know what factorial means, so let's do that first. If I write factorial, this is the expression. I know in English class it's an exclamation point, like wow, but in mathematics, the factorial means this. If I give you 6 factorial, I mean 6 times 5 times 4 times 3 times 2 times 1. What do you think 10 factorial means? That's right. 10 times 9 times 8 times 7. I'm not going to write that one, but you get the hang of it. So we have to use factorials when we're using this binomial theorem. but it's pretty cool. So let's see if we can get this answer here. So we want the 10th term of a plus b to the 15th. So I'm going to write a fraction bar and n factorial. So in this case, 15 factorial. A, b, let's see. I want the 10th term, right? So for the k plus first term, this is k, so that's 1 less. So this is 9. And this is n minus k, so 15 minus 9, 6, all right, over n minus k factorial, which is going to be 15 minus 9 factorial. And then k plus first, so k is 9, so 9 factorial. And 15 minus 9 is 6 factorial. These two numbers are usually the 2 factorials, so that's kind of a cool thing to be able to do. So rewriting this, I've got 15 factorial. So 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8, dot, 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 all the way to 1. Then I have a to the 6th, b to the 9th. I have 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. Then I have 9 factorial is 9 times 8 times 7, dot, 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 all the way to 1. Hey, those can reduce. There we go. There's a cute little shortcut. Then I could say 6 times 2 is 12. Cross out that 12. I could do 5 into 15 is 3. I could do, does 3 go into anything here? Not nicely. 2 goes in there, 2 and 7. So now I just have to multiply 3 times 7 times 13 times 10 times 11 times 10 and get some big number, right? You can use your calculator for that. Some big number over 6. It won't reduce. A to the 6th, b to the 9th.